Good day, everyone. This next video is concerned on the second special right triangle. Again, do not forget that the shortcuts that are possible for the special right triangles are just patterned on the Pythagorean theorem. But since we have these special right triangles as we name them, we have shortcuts for that. And since this next given here is in the form of a 30, 60, 90 right triangle, look at the angles. We have a 30 here, we have 60 here, and I have the 90. This is also again known as a 30, 60, 90 right triangle. We would also have a shortcut for the determination of the sides, even if one side is only given. For item number one, we are only given with A, which is also known as the side opposite the 30-degree angle. The side opposite the 30-degree angle is also known as the shorter side. So all of the values for A here are considered to be the shorter side. The side opposite the 60-degree angle is considered to be the longer side. And then our C here, the opposite the 90-degree angle is of course known as the hypotenuse. Now, to solve for the remaining sides out from the shorter side, there is a shortcut for this. The shorter side, let's look at the hypotenuse first. The hypotenuse is also known as the double of the shorter side. Okay? In this case, we are going to use these variables here so that we will not be confused. C is equal to twice the value of A. In this case, if our A is 3 as given in number 1, the value for our C in number 1, which is the hypotenuse, is 6. That's the value here. As for our longer side, which is B, it is known to be the square root of 3 of the shorter side. Okay? Square root of B of the shorter side. That would be if A is 3, the value for the longer side is actually also B. The value of the longer side is also given as 3 square root of 3. If you're not convinced with this, even with the proof found in our module, let's try to check it using the Pythagorean theorem. We all know to be c squared is equal to a squared plus b squared. And substitute the values for a, b, and c. C is 6 squared. A is 3 squared, question mark. B is 3 square root of 3 squared. 6 squared is 36. The other side will have 9 plus, distribute that. Square of 3 is 9. Square root of 3 is 3. Removing the radical sign. You have 36, question mark. 9 plus 27. That's 27. So you have 36 is equal to, check, 36. That would mean the solutions are correct and the values for C, hypotenuse is 6, and the longer leg is 3 squared of 3. Conversely, if we talk about from the shorter side to the hypotenuse, multiply it by 2. When we return it, we are going to divide it by 2. Okay, let me write it here. From shorter side to longer side, we're going to multiply by 2. When we're going to return it, we're going to divide by 2. Similarly here, from shorter to the longer leg, you're going to multiply by square root of 3. When we go back, we're going to divide by square root of 3. Okay, let's try to do that for the next items. Number 2. In number 2, the given is the hypotenuse 24. From here to there, we will divide this by 2 because we all know that the measurement of the hypotenuse for a 30, 60, and 90 right triangle is twice the shorter leg. So if C is given to be 24, the shorter leg must be divided, it must be divided to get the shorter leg. So the shorter leg, sorry, The shorter leg A will be equivalent to 12 divided only by 2. So that's 12 here. And then we already have A. So to get to B is simply A squared of 3. So it's equivalent to 12 squared of 3. That's the value for B. 12 squared of 3. Okay. So basically, if your values for your shorter leg are in expressions without radical expression, your hypotenuse will also not have radical expressions and vice versa. But your longer leg will have a radical expression of square root of 3. But if we're going to reverse it, let's say B in number 3 is given without a radical expression, we would expect that the shorter side and the hypotenuse will contain a radical expression. Let's try to check. Since we have B here, which is 12, and we all know that B is A times square root of 3, let's try to substitute here 12 and solve for the shorter leg rather. So we will divide this by square root of 3, square root of 3. To remove that, A is 12 over square root of 3. Rationalize it, square root of 3, square root of 3. You have 12 times square root of 3 over square root of 9, which is a 3 squared, 3. And then finally, it could be simplified as 4 square root of 3. Again, as I have mentioned earlier, since our again, as I have mentioned earlier, since our longer leg that did not contain any radical expression, it shall be given to our shorter leg. And with that, we also know that C is twice A. So twice 4 square root of 3. So you will have 2 times 4, which is 8 square root of 3. Please review your radicals. You cannot multiply 2 and 3 here because 3 is is a radicand. So multiply only coefficients 2 times 4, 8. That's the value for your C. So 8 square root of 3. If you're not convinced with this, you could always check using the Pythagorean theorem about the relationships. Let's just try number 3 to check for the Pythagorean theorem. So you have 8 square root of 3, that's your C, squared must be equal to 12 square, A. 4 square root of 3 squared plus 12 squared. Distribute, that's 64 times 3, question mark pala. That's 16 times 3 plus 144. 64 times 3 is 192, if I'm correct. 16 times 3 is more or less 48. Sorry for that. 48 plus 144. When you add them up, 192 is equal to 192. This means that the results for number 3 are all correct. You may check number 2 for that as well using the Pythagorean theorem. Again, these are the results for this practice exercise. Please review for in preparation for our assessment. Thank you very much. Goodbye.